Yes, so GMR site where you have deployed the private 5G is around 3 to 4 square kilometer area. And they have quite a few very big buildings where the energy, power generation, etc., are taking place. There is some coal handling area, right? So it's a huge outdoor area, plus also an indoor space needs to be covered. So they have Wi-Fi at this point, predominantly used for within the building coverage for their IT operation, and the public Wi-Fi 5G network or 4G network from the operators are not really great because it's in the outskirts. And on top of that, they wanted to create a air gap network, that is a private captive network which doesn't connect to any public network, right? So that's a very important thesis for them because they need to keep their data secured private. At the same time, they want it to be kind of non-vulnerable to any cybersecurity threats, right? Because energy sector is one of the areas which are kind of places where the cybersecurity threats happen generally, right? So they wanted it to be mission proof, like for that. So, and the operational use cases they wanted to cover is like energy, like the automation of the the energy plant, then worker safety, fleet management, surveillance, like all those things need mobility also, like the fleet management needs mobility, drone survey needs mobility. So they wanted a private network which supports mobility and which also supports higher uplink bandwidth, like videos, like video surveillance or like drone, real-time drone monitoring with video cameras would need a lot of high uplink bandwidth, not downlink. So they wanted a solution which supports all those in real time. And that's why I think they were totally, they have done the research themselves actually, and they went with private 5G for mobility and real-time responses. And also they wanted automation, so they wanted an edge AI kind of solution, a private cloud to be deployed on-prem. So that was the main reason they went with the private 5G and the edge AI approach.